Remember in Unit J, whenever I said that this will not be the last time that you factor and you need to remember your rules? Well, this is one of those days when you need to be able to remember your rules. We're going to solve these quadratic equations by factoring. If we have multiple answers, we're going to separate them with commas. They're not going to give us 2 boxes. They're just going to give us 1 box on this. So factoring, what was the very first thing to do whenever we're factoring? To see if there's a greatest common factor. In 49 and 2, nothing goes into 49 and 2 besides 1, but there is a g in both of those. So we're going to take a g out. And now that it's factored, we're going to do what we did in case 7 and find our zeros. So this one is g equals 0. And then we set 49g minus 2 equal to 0. We add 2. And then we divide by 49. So 2 over 49. So in your box, you can put 0, 2 over 49. Or you can put 2 over 49, 0. It doesn't matter which one. 25 and 22, nothing goes into those, but there is a z in both of them. So we're going to take a z out. This z equals 0. And if you figured out the pattern by now, we take the opposite of positive 22 and we put it over 25. And that doesn't reduce. 1, 7, and 12, nothing goes into those, and there's not a v in everything. So we have a trinomial, but goodness, our leading coefficient's 1. So we put a v and a v, we bring our first sign down, then a negative times a positive is a negative. So we're going to multiply to get 12, and we're going to add to get 7. What does that? 4 and 3, but now that we've factored, we find out our zeros. So this would be 4, and this would be 3. 32 and 72. You know, I'm not going to factor this one because it's a t squared, and it's just like what we did in case 6, I think it was. Yeah, case 6. So we're going to add 72. We can do this if we don't have a b. 32. That reduces by 2 and gets 36 over 16. That reduces by 4 and gets 4 over 9. So t squared equals 9 over 4. That's like 4 over 9. And then we plus or minus the square root of that. So we have a positive 3 over 2 and a negative 3 over 2. Because the square root of 9 is 3 and the square root of 4 is 2. If you notice that this is a difference of squares, 3x and 3x gives you 9x squared, 4 and 4 gives you 16, and a negative and a positive gives you a negative. So this would be positive 4 over 3, and this would be negative 4 over 3. Trinomial with a leading coefficient not 1, so we got to take the 4 over here. Positive and negative 32 and 1, but then we have to put the 4 back in. So m plus 8. And on this, if we were just factoring, we put the 4 back in, or 4 with the m. But because I know we're solving, we can leave it like this, because what would make this 0? Negative 8. And what would make this 0? A positive 1 over 4. Same. Take the 3 over. 42. S plus 7. 3 and 4. 14. 3 and 14. So 14 and 3, then we put our 3 back in. So this would be a negative 14 over 3, and this would be a negative 1 because 3 over 3 is 1. The opposite would be negative 1. This is a perfect square because I can take the square root of both of these. So that would be 5m plus, because of that sign, 4. So it would be negative 4 over 5.